15, structure and graphs of polynomial functions. It says in the opening exercise that we're going to sketch the graph of f of x equals x squared, the graph of x to the fourth, and then what will the graph of x to the sixth look like. So they want us to graph just a quick sketch. I mean, it does not have to be perfect. I have a grid here to aid in that. There's not a grid in your book per se, but you're welcome to draw a little x and y axis if you want. I'm going to draw a little table here that's going to help us with our sketch. And so we're going to graph the sketch of x squared. So we're going to have our x values here and our y values, which are x squared, and we're just going to do some of the negatives, some of the positives. So like if we did -3, right, -3 squared would be 9. If I did -2, -2 squared would be 4. If we did -1, that would be 1. And then 0, of course, would be 0. And then if we just did a couple in the other direction, that would be 1, 1, 2, 4, and 3, 9. That gives us enough to get a sketch going. Right, I'll increase our table. And so if we graphed them, let's see, -3, now let's see if we ever have 9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here, -2, so 1, 2, 1, 2, 3, 4. -1, 1, 0, 0. And quadratics are mirror images of themselves. So we know those go there. And so this would be the sketch of x squared, right? Even I have a sketch. It's not going to look perfect. And we'll just label that one as x squared. So we'll compare it and do the same thing. So we can do another table. And we can do that for x to the fourth power. So x and then y equals x to the fourth. So if we did x to the fourth, let's see, our number is going to be a little more limited. -2 and 16. If we did -1 and 1, 0 and 0, 1 and 1, and then 2 and 16. Now 2 and 16 is not going to fit on the grid, but we'll approximate. So let's see, -2, this is 4, this is 9, 10, 11, 12, 16 is going to be like somewhere up here. -1, 1, 0, 0, 1, 1, and then the same reflected over here. And you can see that it's going to come through and sketch and go back up this way. This would be x to the fourth. And if we just compared x to the sixth, right, so one more table, x, and then y would equal x to the sixth. Again, those numbers grow quickly. So you get -2, 64. These would stay the same. And then +2 would be 64. So again, these three dots here would match, but then it would go up even quicker and sharper. And so you can see as my exponent increase, my graph becomes more and more narrow in this design. And so I think the most important takeaway here that I want you to take away is notice that both ends, this end and this end, both go in the same direction, up. This one and this one both go up. This one and this one both go up. And so ultimately that's going to be our big takeaway as we look at this. And so that's just the opening exercise, was to sketch what is x squared, x to the fourth, and x to the sixth looks like. Your graph does not have to be perfect. Your takeaway should be that the larger your exponent, the more narrow your graph becomes. but the negative 1, 1, 0, 0, and 1, 1 all stay the same regardless of the exponential power. It's just the other numbers increase quicker at that point going forward. So they ask us to look at example number 1, which they say to graph x to the third power, x to the fifth power, and x to the seventh power. So it might also be worth noting that these functions here, right, if we circle them, x squared, x to the fourth, and x to the sixth, these are even exponents. So we'll make that note. And if you look here, they want us to graph the sketch of the graph of x to the third, x to the fifth, x to the seventh. These are all odd functions. And again, they just want us to sketch at this time. So if we did x to the third, x to the fifth, let's see, here we go, and then x to the seventh. So if we looked at these, right, x to the third, so we'll draw a little table. Table of values are nice. So there's one table. We can do another table and a third table, put them all on there at one time. So we'll have x, and then y is going to equal x to the third. So if we did that one, that would be like -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. You kind of start to notice a pattern here. So -2, and then 1, 2, 3, 4, 5, 6, 7, 8's already off the edge of my graph. -1, -1, 0, 0, 1, 1, and then 1, 2, 3, 4, 5, 6, 7, 8. So you end up with a different kind of graph here. It kind of goes in this way, scrolls down, and goes down this way. If we compared that to x to the fifth, right, you're going to see the same kind of idea going on. For -2, it would be -32. And then you got your -1, -1, 0, 0, 1, 1, and 2, 32. So if we attempted to graph that, these again would stay the same. But my -2, -32 will come down even more narrow. And so the graph is going to start to come down like this and go down like that. Same thing if we did x to the seventh, right? It would come down even more narrow and have even less of a curve to it in that design. So those are the sketches. Now to really appreciate it, let's clean it up, right? Those are hand sketches, so we follow the book's directions. But let's take a look, and what if we did it digitally? So if we did x squared, right, this would look like this. And we'll slide this down. And then if we did x raised to the fourth power, you can see it's even more narrow. And if we did x to the sixth power, you can see that's even more narrow. You can see that all of them go through -1, 0, and 1. But other than that, the graph gets more and more narrow as we go along. If we were to be curious and type in x to the eighth, you can see it gets narrow once again. And then if we do the same exercise for x to the third, right, x raised to the third power, and then if we did x raised to the fifth power, you can see it's getting more narrow. I can zoom in a little bit so you can see the behavior. And then if you have x to the seventh, right, you could see, and again, all of them have in common the -1, -1, 0, 0, and 1, 1. But other than that, you see the graph start to get more narrow, flatter in this region with a different kind of curve, and then it becomes more narrow as you go forward. If we were to be curious, again, we could type in x to the ninth, and you see the same kind of narrowing occur. in the graph as each one plays on. So one function has even exponents, one function had odd exponents. That's one thing that we are considering and looking at in this behavior. So it is worth noting that look at our odd functions. Every single arrow on this end goes up. Every arrow on this end is going down. And so you get this general curve that goes like this. Whereas if we go back and look at the quadratics, the general curves was one was up in this direction and the other one was up in that direction. So you have something called even functions and something called odd functions. Even functions tend to have their endpoints go up in both directions, or vice versa, they could both go down. Whereas in an odd function, you got one side going up and one side going down. And this could also be the other direction as well, but they kind of have this different design in their pattern. So what do they ask us to do in these exercises? Exercises A through D, we'll go through probably A and B for sure, is to graph these in a graphing utility. That'll be our Desmos. Notice this has a mixture of both even and odd degree terms. And so they're curious if that's the case. If we have even and odd, like see here's 4, that's even. 3 is odd, 2 is even, 1 is odd, and this one has none. Predict whether the end behavior is going to be like example 1 or the opening exercise, right? Do we expect the graph to have an even characteristic such that it looks more parabolic in shape? Or do we expect it to have more like an odd function, which the endpoints would look like this? And that's what they want us to know. They want us to use a graphing utility to check our prediction. So let's see what's going to happen, right? We could type in 2x raised to the 4th, and then plus x raised to the 3rd, minus x squared, plus, plus 5x, and then plus 3. And so we zoom out a little bit and just kind of get an idea, right? We have this look in our shape, right? We could take our x-axis, by the way, we can shrink the x-axis. We maybe change this to -15, maybe -5, and we'll go this to 5. And we can see what our function is doing. It seems like both endpoints are going up. And so this would have the characteristic of an even function. So this is the one, the characteristic that it tends to follow. And you'll note that it tends to follow the exponent of the leading degree. And so since the largest degree is a 4, we end up with an even function. So here in exercise 1 part B, same idea. Notice we have an x to the 5th. That's an odd value. So in our prediction, I'm going to predict that we're going to get an odd style function, something that's going to kind of go like this. Well, maybe not perfect, something in that idea. So now that we made our prediction, we're going to graph, and let's see what happens, right? So we type in 2x raised to the 5th minus x raised to the 4th minus 2x raised to the 3rd plus 4x squared plus x plus 3. And you see this general kind of motion occurring, where you got one end behavior going up, the other end behavior going down. We can always zoom out to see that that trend continues. And so that confirms our prediction that this is indeed an odd function because the leading degree is going to be odd. Okay, so that pretty much wraps up that lesson. We're not going to do exercise 1C or 1D, and we're not going to look at exercise 2 at this point. The takeaway of this lesson, just to wrap it up, in case you're not sure what it is exactly we did, is we wanted to be able to acknowledge that there are something called even functions, which the endpoints go in the same direction, either both up or both down, or we have something called odd functions, where one end goes up and one end goes down, and then this could be reversed in the other direction as well. And so that's pretty much your large takeaway from today. All right, so next to the problem set.